Dear friends, we shall discuss the most important problem of complex numbers. If m and x are two real numbers, show that e to the power 2mi cot inverse x into xi plus 1 whole upon xi minus 1 whole to the power m is equal to 1. Please watch the complete video. If you are new here, please subscribe the channel. Friends, first of all, you have to observe here. There are two terms which are in product form and one power is common. This is m. So first of all, we shall not try with this power. We shall finally raise to the power m. So friends, we consider that cot inverse x is equal to theta. Therefore, cot theta is equal to x. So friends, we can write tan theta is equal to 1 upon x. Okay. So tan theta is equal to 1 upon x. First of all, we take e to the power 2i cot inverse x. Now friends, e to the power 2i cot inverse x can be taken in this form. This is e to the power I into 2 cot inverse x, and cot inverse x is equal to theta. So this is e to the power I to theta. Okay. So you know this form, this is Euler form. We can write it as cos 2 theta plus I sine of 2 theta. Okay. Now we break it. Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta plus I into 2 tan theta divided by 1 plus tan square theta. Okay. So friends, here we can write this is as 1 minus tan square theta. What is tan theta? Tan theta is equal to 1 by x. Okay. We can write it as 1 by x square plus 1 plus 1 upon x square plus I into 2 into 1 by x divided by 1 plus 1 upon x square. Okay. So friends, we here do the LCM. This one is x square. So x square minus 1 divided by x square plus 1 upon x square plus I into 2 upon x divided by x square plus 1 divided by x square. Friends, now we can write it in this form. Again I write e to the power 2i cot inverse x as equal to, here x square is cancelled, so this is x square minus 1 upon x square plus 1. Okay. Plus I into 2x upon x square plus 1. Now we shall find the LCM. The LCM is here. LCM of the denominators are x square plus 1. So this is x square plus 1 and the numerator becomes x square minus 1 plus I into 2x. This is equal to x square plus 1 and minus 1 can be written as I square. So this is x square plus I square plus 2ix. So the numerator becomes x plus I whole square upon x square plus 1. Now this x square plus 1 can be written as x square minus I square, because I square is equal to minus 1. So minus of minus 1 is plus 1. So friends, this can be written as usual x plus I whole square, and the denominator is now x plus I into x minus I. So 1x plus I is cancelled. So we have now x plus I upon x minus I. Friends, we take I common. So I into x upon I plus 1 divided by I into x upon I minus 1. Okay. This I is cancelled now. So we are getting this as 1 by I means minus I. So minus ix plus 1 divided by minus ix minus 1. So this can be written as ix minus 1 divided by ix plus 1. So friends, we started from e to the power 2I cot inverse x, and now we have got it here ix minus 1 divided by ix plus 1. So this is the time to raise the power to m. Okay, so on the both sides we shall now raise the power. So we have to change actually the paper. So from the beginning we have to start it. This is e to the power 2I cot inverse x. We have actually get this one ix minus 1 upon ix plus 1. So we write it on the right side, and this is e to the power 2I cot inverse x is equal to ix minus 1 upon ix plus 1. So we shall now raise the power. Okay, e to the power 2I m cot inverse x is equal to ix minus 1 divided by ix plus 1 whole to the power m. Okay, so friends, now we want to transfer this right side to left side. So this will be now e to the power 2I m cot inverse x into ix plus 1 upon ix minus 1 whole power m is equal to 1. This is actually the proof. This is the proof. You see, in your question it was, if m and x are two real numbers, so that e to the power 2 mi cot inverse x into xi plus 1 upon xi minus 1 whole power m is equal to 1. So the proof. Thank you. Have a nice day.